very easy, simple. Unlike the previous one, this is easy for you. All right. So what I'm going to do now in this lecture, I'm going to talk about various kinds of components you can combine artificially to make a soilless substrate. Again, these are all artificial stuff, right? And so why is this important? When you go to the market and you buy a big, pile of artificial media, you need to know what is inside. They will say you have coir in it. They will say probably you have perlite in it, vermiculite in it. What do they mean? Why do you want more of one versus the other? What are the benefits and disadvantages of one medium versus the other? Those are the kind of things we'll talk here. We're going to go with one component at a time, one media component at a time. So the first thing I want to say is general formula for a soilless substrate. General formula: 75% organic, 25% inorganic. General formula. Now it can be 80-20, it can be 70-30, whatever it is, but the general formula: 75% organic, 25% inorganic. Okay, that's how you want to mix. So what are the organic components? Organic components are coir, peat, bark. These are all organic, right? They're from plant products, organic. Then what are the inorganic components? Perlite. What else? Vermiculite, right? All these are inorganic compounds. Generally, these are the major inorganic compounds. So it's all now about mixing them in different proportions. Simple. But before we mix them in different proportions, we need to understand each of them. Each of them have their own advantages and disadvantages. Knowing that is important when you prepare a mixture. Okay. So the first and foremost thing I want to talk about is peat mass. That's how it looks. Somebody said brownish black in color. You see that? Somewhat like brownish black in color. Sphagnum peat mass. Peat mass. It's also available in India, but the reason why you don't see a lot of peat in India is that this comes from Canada. That's why it's called Canadian sphagnum peat mass. It comes from Canada. Peat bogs. Peat bogs are naturally formed, basically carbon sinks. I'll talk about that in a minute, but that comes from Canada. So Canada is far away. Shipping costs will make the peat expensive in India. But on the other hand, coir comes from what? Coconut plants. And you got a lot of coconut plants everywhere in India. In Indonesia, Sri Lanka, all those countries, they have lots and lots of coconuts. Even South Africa, Madagascar, South Africa, those areas, coastal areas. So you harvest coconut from there and you make coconut. It's a mesocarp. So if you look at the coconut, the outer layer is mesocarp and it's that mesocarp. But what they are doing is they take that nice good quality fiber and then they make those nice mats. You know the mats? Mats and fancy ornamental things, expensive things. And when they are doing that, powder is a sort of like a something that comes out of it that you don't find any use. They started using that powder to prepare coir. So not the expensive mesocarp, but the leftover stuff is used to prepare coir. Okay, but it is available everywhere, and that's why coir is important here. But peat is the dominant organic substrate globally. So let's talk about peat. Some of the characteristics of the peat. Peat has nitrogen in it, about 1% nitrogen. So it's an added value. You are not just buying peat, you're also getting some nitrogen with it, 1% nitrogen. That's good. It's got high water holding capacity. That's nice. You will see that even with coir. But the most important thing I want to remember is peat is acidic. It is acidic. Later on, I think towards the end of this week, I'm going to talk about EC and pH. When we talk about pH, I'm going to talk about acidic and basic nature and how that affects nutrient uptake. But for this class, please remember peat is acidic. Very, very acid-like. An example of something that has acidity of 3 to 4 is if you like really Coke or Pepsi or Thumbs Up, their pH is 3. So you're drinking acid. Okay, all right, remember that. It's not good for health. That's one of the reasons why it's not good. The other reason is it's got ton of sugar in it, so that also is not good for health. But in any case, peat is acidic. Carbon nitrogen ratio 60:1. Isn't that what I recommended? 60:1. So good. Peat has got good carbon nitrogen. So you got check box. So the advantages are good water holding capacity, good nutrient retention. It's got good carbon nitrogen ratio. But there are two problems. One I already described, it's acidic in nature. But the other problem is it's got poor AEC. AEC stands for exchange capacity. It can't hold nitrates and phosphates. So when a medium doesn't hold nitrates and phosphates, anions, the smart way of fertilizing plants is to not apply too much at a time. Apply small quantities over time so you don't waste it. Plants take whatever you apply, come back next day, apply a little bit more, they take whatever they need. But if you apply too much of it, they get leached out, wasted, causes environmental pollution. All right? There is something I want to point to about peat. There is an increasing resistance to not use peat, because peat, you're all aware of global warming, climate change. What is causing climate change? Carbon dioxide levels in the atmosphere. Peat is a carbon sink. You know what it does? 20% of carbon, terrestrial carbon, is being held by peat. It's in there. Okay, the carbon dioxide in the air, peat absorbs and holds it inside. And when you dig it up, dig this peat box and prepare peat medium, you're releasing the carbon dioxide. You're adding carbon dioxide to the atmosphere. So it's contributing to global warming. For peat box to naturally form, it takes centuries, not 1 or 2 years. They are naturally forming things. It takes centuries for peat box to happen. And here we are digging them, using them, and at least you are telling me that we will reuse them. But most often we use them one run, throw them away. We are disturbing the environment, these peat bogs, and on top of that, when we dig the peat bogs, it releases carbon dioxide. So there is an increasing resistance to not use peat anymore. Don't use peat. Look for alternatives. And that's the reason why coir became popular. Otherwise, nobody was interested in coir before. They were all about peat. Okay? So let's talk about coir then. Yeah. Go back.
Sir, in this, the pH of peat is acidic and after that limestone is added. So is it lime or limestone?
It's calcium carbonate. Lime. Calcium oxide, calcium carbonate is limestone, calcium oxide is lime. It's the calcium that matters, not anything else. Did I miss that point?
This is the fourth point.
Yeah. But I'm going to show you. So what happens is, if I wanted to hold off to that point until we talk about the pH chapter, because it's going to get confusing now if I talk about why or how that the pH raises when you add calcium carbonate. So let's hold on to that. But peat is acidic. If you remember that, that's good for now. Okay. Coir, on the other hand, has some of the benefits just like peat. It also has good water holding capacity. It also has good nutrient capacity, but coir is not acidic. You see here, it is sort of more towards the alkaline side, basic side, coir. Okay, you see the pH is close to 6.5. Pretty neutral, actually, to be honest with you. Pretty neutral. So it's good. Coir is good. But the problem is it's got a high carbon to nitrogen ratio, 80:1. There is more carbon, less nitrogen. What does that mean if you have more carbon and less nitrogen? What happens to nitrogen? Will be used by bacteria or microorganisms, anything, not just bacteria. So the microorganisms now feed on that nitrogen and make the nitrogen immobilized, meaning it is not available to plants. So if you are going to use coir for producing your plants, be aware that it's got high C/N ratio, which means you may have to supplement more nitrogen during production. Okay, if you may start seeing nitrogen deficiency symptoms, and if you see that, then you may have to apply a lot more. Okay, coir has that one disadvantage: high carbon nitrogen ratio. The other problem, I think it's less of a problem now, but the other problem was, where are the coconut plants normally located? And what do you see in the coastal sands? Salt. So coir used to be, and I think even still, when you actually look at composition of coir, there is sodium chloride in it, salt in it, and that salt is coming from ocean. So they are cleaning it a little bit, but that problem still lingers. Okay. Initially there was a problem with coir. I think that is now fixed. The initial problem was coir was coming from Madagascar, from Indonesia, from Sri Lanka, and the plants in these conditions, they were different, and there was no uniformity. Remember I said substrates, one of the advantages soilless substrates, they should be uniform. But here we are getting coir from different countries with different chemical composition, different carbon nitrogen ratios, different anion exchange capacities, different cation exchange capacities. That was a problem. I think the industry is now streamlined. They are making sure that that is kind of taken care of now. But I think still the sodium chloride problem still exists because it comes from coastal areas. Okay. It is extracted from the outer husk mesocarp of the coconut basically, but it is not the fine fibers. Those fine fibers are used to make mats or some decorative material. Whatever is left over after that is used in coir preparation. The advantage of high carbon nitrogen ratio is less shrinkage, right? You see, if you have high carbon and less nitrogen, nitrogen get mobilized, that's a problem. But if you have less carbon and more nitrogen, then the media can shrink. That problem is not there in coir. Coir media will not shrink, but peat mill can shrink. Okay? When media shrinks, it loses water holding capacity, nutrient retention, and also aeration. All those things will go down as the media becomes smaller. But the main things I want you to understand is coir is very similar to peat. The advantage is it's pretty close in terms of pH, it's neutral pH, whereas peat is acidic. You got to add limestone or lime to bring the pH up. Coir is becoming increasingly uniform now and becoming popular, especially in this part. And I've even seen coir in Central America. When I visited some Central American countries, they're actually using coir slabs to grow strawberries. And I think coir is a wonderful option, alternate option for peat. And we should stop using peat because it's got some environmental concerns. Okay. So those are the two major organic components. Now let's look at the inorganic components. The first one is vermiculite. Vermiculite is like a mica-like a material, it's a silica-like material, okay, and like a mineral. So what they do is, in this particular mineral, there are layers and layers and layers, okay. When they moisten the mica and then silicate minerals and then they heat it, what happens is those layers kind of open. You know the harmonium instrument? When you open the harmonium instrument, close it, remember, that's exactly what is happening for the silicate materials when you heat them up. They kind of open out a little bit, they open out. When they open out, what are they creating? They are creating space where all those nutrients can get absorbed. More space is better. So that's what is happening. And also when you open up any mineral, the mineral becomes lighter. So you are heating mica like silicate mineral, you're opening up those layers, you're creating more surface area for retention of nutrients, but then you're also making it lighter. That is vermiculite. So vermiculite can hold nutrients, and water. Big advantage. But there is one other nice thing about vermiculite. Vermiculite is alkaline in nature. Peat is acidic. Vermiculite is alkaline. When you combine both of them, you get neutral medium. So that's the reason why if you're using peat, the recommendation is always add vermiculite with it. They balance each other. Peat plus vermiculite. Both of them are good with water retention, both of them are good with the nutrient retention, and they complement each other in terms of pH. The substrate becomes more towards neutral nature. So that's the wonderful thing. So always add vermiculite to peat, and usually up to 20%. Usually up to 20% of the total volume. Peat 80%, vermiculite 20%. Perfect mix. Okay. The other one, the second one is perlite. That's how it looks, perlite. Perlite is nothing but, volcanic rock, and you heat it. It's like popcorn. You take a seed of popcorn, you put it in an oven or microwave, it pops up, becomes lighter, opens up space, right? So it creates more space. But the one thing I want you to remember, the difference between vermiculite and perlite is vermiculite is active, it holds nutrients, it holds water. Perlite is inactive, nothing, you can't hold anything on perlite, not even water. So perlite is pretty much like an inert material. You just add it to create more space, more macropores. That's it. Nothing more than that. It also decreases the weight of the medium because it's pretty light in nature. That's all the benefits of the perlite. It's very inert. It doesn't hold water. It doesn't hold nutrients. It just creates more macropore space and makes the medium more lighter in nature. Okay. On the other hand, vermiculite can hold nutrients, can hold water. When you open up those layers, that space is used to hold nutrients and water. That's the benefit of vermiculite. But perlite, on the other hand, it's not the case. Okay. Before I dive into the next type of substrate, which is mostly used in hydroponics, now you know two organics and two inorganic substrates: peat and coir, vermiculite and perlite. Okay. They are mixed in different proportions. You can do whatever you want, but this is what I want you to remember. The companies who sell soilless substrates, media, they claim a lot. They say that this media can be used for tomato, this media is for pepper, this media is for leafy greens. Nothing like that. Nothing like that. All nonsense. I'm saying that and being recorded too. Nothing like that. All right. In my opinion, there are only two types of media. One media is for germination. The other media is for big plants, growing big plants. That's it. There are only two types of media. One is for germination purposes. The other is for adult plants, growing plants in big pots. Let's talk about them. So what does germination require? Number one thing. Germination requires what? Not little bit, a lot of water. Number one thing for seeds to germinate is water. So now, when I am saying that this medium is good for germination, what is it containing? Organic and inorganic, what is it containing? So let me repeat the question. I want you to come up with a mix, a soilless substrate mix for germination purposes. What organic and what inorganic components would you mix to prepare a perfect germination mix? Peat and vermiculite. Anybody has another recipe? Why peat and vermiculite? Both of them hold water and also nutrients, aeration probably less. But what happens if you add perlite then to that medium? It creates what? Macropores. Can macropores hold water? No. But germination requires a lot of water. So a germination mix simply contains peat and vermiculite. With 80% peat, 20% vermiculite, the best germination mix for water retention, nutrient retention, and good emergence, seedling emergence. Simple. And you now know the reason too, right? But for growing plants in pots, we need aeration. We need roots to grow. We need roots to absorb oxygen from the spores. And for that, what is the ideal mix then? For growing big plants in pots. Will the germination mix work? Or do you want to create a new recipe? What is the new recipe then? So give me a proportion, percentages. I want to know percentages. She says 60, 60, 20, 20. Any other recipe? We're just debating amongst ourselves, right? That's it. Any other recipe? 50, 20. Rule of thumb, keep organic close to 70%, at least 70% or 75, okay? 70 for this 70. So 70 is peat or coir, check box. Then the remaining 30 is what we are playing, right? So keep 20% vermiculite, maybe 10% perlite. Or even the opposite way, 10% vermiculite and 20% perlite. That's your growing mix. You have a germination mix and you have a growing mix. That's it. These are the only two mixes. If you want to grow tomatoes, peppers, anything, you use the growing mix. If you want to germinate seedlings, use a germination mix. Companies may say many things. They may say this is tomato mix, this is pepper mix, this is cucumber mix. Nothing like that. Okay, they're all soilless substrates. It's just a little bit of different proportion. They purposely probably do different proportion to make it different from other company. That's all. Nothing more than that. But again, rule of thumb: 70 to 75% organic, 20 to 25% inorganic. Just play a little bit with vermiculite and perlite when it comes to germination versus growing. That's it. Yeah.
So when we are talking about the pH in these, you previously told that we'll add peat with vermiculite to neutralize the pH.
Right.
But in the coil one, the pH is around neutral only.
Correct.
When we add this vermiculite, the pH is higher than.
It can go slightly higher. So again, it's a range between 5 to 6.5. It may go maybe slightly higher, but hold on to that question until pH is a very dynamic thing. You may maintain a perfect mix, and you can't, but still you can't expect that pH is always going to be neutral. pH is affected by the fertilizer you apply. pH is affected by the substrate composition. pH is also affected by the plants you grow. pH is affected by the water you supply. All those things affect pH. So it's a very dynamic property. We have to manage it. We'll talk about that when we talk about pH. But it is not going to increase significantly. It may add a little bit higher. The pH may go up to maybe 6.5 to 6.7. But that's that. All right. So 2 organic and 2 inorganic, the best ones, coir is replacing peat. And you know why vermiculite or why perlite. What is the benefits of perlite versus vermiculite? As long as you know that, you can prepare your own mixes. The perlite, they actually sell perlite, vermiculite, peat, everything is sold separately also in bags. In the United States, we just go to grocery shop and buy a big peat bag or big coir bag. We also buy perlite and vermiculite separately. I think you go to Amazon, you'll find it. Definitely. Just Google out and go for Amazon and type perlite and then sell perlite bag. Oh, there are a lot of companies. There are a lot of companies, and it's a very well known product. It's also an inorganic product, so you probably get a very good quality. As long as you go with a reputed company, you're good. But there are so many companies, so many companies. Yeah. But if you are into research, you may want to create your own recipe, right? You want to look at what happens if you change vermiculite composition versus peat composition or coir composition on flower growth, water returns, things like that. Then you need to buy these individual components and prepare your own custom mixes. But if you are a big producer, you buy in bales, right? Big bales. The bales are about this big. And then you have a big bale of coir, you have vermiculite and perlite. You should have mixing way to mix them mechanically, because you don't want to all the time manually mix them, right? So that is also fine. But if you buy from commercial companies, you pay more because it's a company and they won't sell it until they get a profit, right? Usually big greenhouses, they don't buy from commercial companies. They usually buy big bales from commercial companies. The commercial companies also sell big bales. You buy bales of coir or peat, and also you buy in bulk vermiculite and perlite, and you mix your own way, your own recipe. Sometimes farmers keep their recipe secret. They may find that little bit of vermiculite is really good for their crop, so they prepare their own recipes. They won't even disclose that. It's all trade secret. Okay. Yeah.
Can we do this also that since peat is lesser used, so can we use a lesser quantity of peat and more of the coir and then make a recipe?
But they're very similar. Yeah, you can do all of that. Absolutely. You can add bark. The one thing I want to mention about peat is hydrophobic. So hydrophobia. Hydro means water. Phobia means repulsion. Okay. So if you dry peat, if let's say you have a pot with peat medium, and it's got plenty of water, then it's good. You add water, it keeps on retaining water. But the moment you dry the peat, it becomes dry, and then you add water, what happens? The water is not held by the medium. Water is repelled by the medium. So water goes through the macropores, drains out. That's called hydrophobic nature. Peat is hydrophobic. It repels water when it is dry. So if you are going to use peat medium, it is very important to keep peat at certain moisture level all the time. Otherwise, it doesn't hold water. You have to apply several times water to again re-wet peat and then start using in production. Okay, so that's another thing. kind of I remember that. But this is the more recent inorganic substrate. Does anybody know what this is? Rock wool. Okay. Who is growing hydroponics? Anybody have seen hydroponics here? You have done it. So we use this a lot, rock wool. We have rock wool. This is called a rock wool cube. We have rock wool, squares, and we have rock wool slabs also, big ones too. What we do is we each of these cubes, it's got a small hole. We take a tray, we put the slab. So in this particular rock wool slab, we have 200 cubes. You can count them, but there are 200 of them. Some of them are less, but usually we get 200 of them. We put them in a tray and we add moisture. It gets a little bit moist. We put a seedling on top of it and you get a tiny seedling, and then you take it and put it in your hydroponic system. I'll talk about that when I talk about hydroponics. There's a separate chapter on hydroponics. But rock wool is designed for hydroponic production. The ease of rock wool makes hydroponics so nice. Okay. They also have peat for hydroponics, but peat is expensive. Rock wool is less cheaper. So as the name says, it's a rock wool. So you take rocks, make them liquefy them, molten rock, and you blow air through it. So when you blow air through molten rock, it becomes wool-like material. That's what it is. And then they compact it, rock wool. Rock wool is more like perlite. It is not going to hold any nutrients. It holds a little bit of water, not like peat, but it is more closer towards perlite. It's like in that it is inert. It holds some water, not many of nutrients, but it's just for hydroponics. Initial stages in hydroponic crop production, you sow the seedlings in rock wool, tiny seedlings, and then when you put them in hydroponic solution, as they grow roots out of it, the rock wool is not even needed. But this is for just the initial phase. You will see some pictures and you will learn about hydroponics later. But this is another medium totally used in hydroponics industry. Again, keep in mind water retention is medium, not high like peat. It doesn't hold any nutrients. It's inert, more like perlite. Okay, different characteristics to differentiate different types of medium. In floricultural industry, there is something called stabilized or elay parts. So here is a seedling, right? And you have the seedling in nice, recyclable, tiny paper material. So the advantage of this is, normally if you want to, you're growing, let's say, tomatoes or peppers, you first sow the seeds, and then they get to a certain stage, and then you transplant them, right? Transplant them. There is always some transplantation shock. When you remove and put them in bigger pots or in some other medium, there is going to be a transplantation shock, and research says that the shock can exist for another 7 days. Then plants recover anyways. But for the first 7 days, there is some small transplantation shock. Here what we do is, we raise seedlings in these stabilized media. All we do is take the whole thing like that and we put it in a bigger plot. There is no pulling seedlings or anything like that. This material is recyclable. It decomposes. So it's a natural thing. It nicely decomposes. You don't have to remove the paper or anything like that. It naturally decomposes. The advantage is this: using this, you can prevent the transplantation shock. So you get a little bit faster growth in the first 4 or 5 days with these elay parts. Okay, it's called stabilized medium. Directly sow in it, and when you feel that the seedlings are of enough stage, you take them and put them wherever you want. No need to separate, remove, take the seedlings and transplant them. You can prevent all of that. So this is another type of more recent. It's used mostly in floriculture industry. Okay, because they have to do a lot of transplanting. All right, I think that's the last slide, and we're making time here. I think that's the last slide. So again, this is a very simple chapter. In this chapter, we basically learned about different components, right? We use to prepare soilless substrates. We looked at organic and inorganic components. Organic, 2 types, coir and peat. Inorganic, vermiculite and perlite, right? And then we also learned about growing mix, germination mix. We learned about peat, characteristics of peat. We learned characteristics of coir, advantage of vermiculite versus perlite. What does perlite do? Mixing perlite versus peat, what are the benefits? These are all the things that you learn. It's very simple stuff, straightforward stuff. And then towards the end, we talk a little bit about rock wool and hydroponics, but you'll learn more about that later. So that's about soilless substrates in general. Okay. All right, makes sense. Is this chapter easy? Okay. Okay. It varies by country. For us, it's in cents, not a big deal. For example, let me go back. This one, rock wool, we get a sort of like a slab with 200 cubes, and that is about $35. About $35. The bigger slabs, 2 feet slabs, are what they use for tomato and pepper production. They come close to $60-70 times 87 rupees, something like that.
So as
But
you said, mostly this is used for germination.
these, yeah, the smaller ones are used for germination. Because you asked this question, let me explain. So what we do is this is what we use to germinate seedlings and up to that stage. Okay, when the seedlings get to this stage in tomato production, the way they produce tomatoes, high-ware tomatoes in the Netherlands is they remove this piece off. It comes up. You can take one piece off. Oops. You can take that piece off with the seedling. Okay, I think I have pictures also later on with the tiny seedling, and now we put it in a 6-inch by 6-inch square. That's also rock wool. Okay, they put it in there. The roots grow into now bigger medium. They are moistening it, and then when the plant get to this stage, tomato plants, they take that square 6 by 6 square and put it on a 2 feet slab. The 2 feet slab will have 3 locations, 3 squares, 1, 2, 3. They put them there, and they put a drip stake and recirculate the fertilizer solution. That's how and as these tomatoes are growing, they string them up high wire, like they grow 6-7 feet tall. And as the plants are growing, they fruit in this area. When the fruiting is over, they lower it, make the vine go round and round and round, and always use the fresh part. And we can talk about that in case if you're interested in high-wire tomato production or high-wire pepper production for that matter. Okay, and that's a crop production aspect. I teach 3 courses related to this. I teach greenhouse management, like what you are hearing from me. This is all about environmental management. Okay, not financial management, environmental management. And then I also teach greenhouse crop production. That's where I talk about tomato, pepper, strawberry production, flower production, bedding plant production, all kinds of crop production. And then I also teach another course called Sensors and Automation. We build our own sensors in our lab. We build IoT sensors. And I think I actually asked one of my students to kind of join next week over Zoom, because I couldn't bring all those sensors. He's going to call in from my lab on the Zoom. Probably we can see him. It's like 5:30 in the morning for him when we are at, in the afternoon here, but he is graciously accepted to come in. So he's going to show you how automation can be done with those sensors, with those microcontrollers and all those automation stuff. So I also teach a course. But for this program, I kind of focus more on environmental management and added a little bit on the technology towards the end. Okay, so that's what this course is. But I'm also coming back, like you heard from Dr. Ashutosh, that I got a Fulbright fellowship. So I got selected as a Fulbright representative from the United States. There are about 40 or 50 of us coming from US to India, and most of them are engineers. I'm the only one in the agricultural area, entire agricultural area. So I want more Fulbright fellows to come from US in the agricultural area, but a lot of them are engineers, and so they go to IITs and places like that. I chose this place to come. I'll be here from January through May. I'm teaching a 45-day course in the College of Agriculture, and that course is about sensors and automation. Okay, if you are interested and if you are here, feel free to talk to Dr. Ranjan Srivastava. He is the one I'm collaborating with, and I'm going to teach that course for 45 days. It's all about IoT devices, microcontrollers, things like that. Quite advanced, okay, digitized systems. But then I'm also going to do a lot of research here. My research project is about reducing or increasing nitrogen use efficiency and water use efficiency using those digital sensors. So we want to irrigate plants and we want to add fertilizer to plants, not based on a timer, not based on our decisions, not based on even sensors that we put in the soil, but we wanted to apply water and fertilizer to plants based on plant needs. The plant is telling us, is sending some messages. That's what we are capturing through those reflectance systems, and using those messages we know when to add fertilizer, when to add water. That is what I'm trying to do, and to see if those systems can actually help in Indian scenario to reduce water use and reduce nitrogen fertilizer use, because you get too much nitrogen being used and is causing a huge problem where you are living, Indo-Gangetic plain. If you take a sample of water in this plain and send it to laboratory and look for nitrates, it's way over sky. It's not good for health. But we're also applying too much nitrogen, causing nitrous oxide pollution. Nitrous oxide is another greenhouse gas, 300 times more potent than carbon dioxide. And we have also a big water problem, fresh water problem. That is the next chapter, okay? We're going to talk about water in the next chapter. That's my research here. I'll see how I can manage that. I never stayed that long away from my family. 10 days is okay, but I do not know. But I'm going to take the challenge on myself. But I may be traveling a lot to south, where my extended family is. So we'll see. That's for some other time. All right, 12:11. I got 45 minutes. One question.
It is using slabs in hydroponic industry or mixed with peat. So how
What's happening is that too much of that is being used. He said he's reusing peat. We wanted to come up with a way to use that rock wool after first production. There's piles and piles of rock wool outside greenhouses, and that's not environmentally good. So somebody said, why don't you mix with? It's just like perlite. When you mix with peat, it creates similar environmental conditions. But the problem is, there will be algae on it. There will be some roots growing into it. All of that will be added to peat. But at least we want to come up with ways to reuse it, so we don't produce too much of that and cause environmental pollution, right? There are a lot of environmental concerns. That's a different topic. I showed you a picture of that Almeria region in Spain, 26,000 hectares of greenhouses, white color. Every 3 years, they replace the plastic. 26,000 hectares of plastic is thrown away. And if you go to that Mediterranean Sea and walk along that, there are piles and piles of plastic sheet. Nobody knows what to do with it. Because 26,000 hectares of greenhouses, they all have to replace polyethylene sheeting every 3 years or 4 years. And the older one, they're dumping near the ocean. Huge pollution issues, by the way. Okay? We don't know the answers. In any case, I don't want you to go anywhere. Just take a 2 or 3 minute break right here, and we'll start the water chapter. Just to, chill out for just 5 minutes. That's it. Okay? Because if you go outside and come back, it'll be another 15 minutes, and we may not have enough time. Okay? The water is an important thing, right? So far we finished light, we finished temperature. Today we finished substrates. The next thing is water. Then after water is our nutrients. Okay? Important cardinal factors, plant growth.